As I was looking through your assignments that you turned in for section 8.2, there were some word problems on the back that I think some of you had a hard time with. So this video is for you that had a hard time with those. And I know it's been a while since you've turned in your section 8.2, but there are a couple of word problems on your quiz tomorrow. So I thought it would be beneficial that maybe I just kind of go through these and just so you have an idea of how we can really solve these. So on number 41, it's talks about finding the height of an airplane, and I drew a picture of what I saw in the book. And it says that an aircraft is spotted by two observers. So our observers are at points P and Q, and those observers are 1,000 feet apart. And as the airplane passes over the line joining them, so the airplane is here, and as it passes over here, each observer takes a sighting of the angle of elevation. So from where they are to the plane, this angle is 40 degrees and this angle is 35 degrees. And it's asking us to find out how high the airplane is. So we're looking for this height. The first thing that I know that I can do is I can look at this and I can find this angle. So let's do this. So this angle right here, if these two angles add up to 75, then this angle right here is 105. Okay, so I'm just looking at the whole picture and just trying to get any information that wasn't specifically given. Now, if I look at the information that was given, I have an angle, I have a side, the length of the side, and I have another angle. So this is actually an angle, side, angle problem. And doing that, or knowing that, I'm going to use the law of sines. Now, if I'm using the law of sines, I do need to have a ratio with an angle and the length of the side opposite of that angle. So I needed to know that this angle was 105 degrees. So one of my ratios is going to be sine 105 over 1,000. And then I need to set that equal to another ratio to find the lengths of one of these sides. And my thought process in that is if I know the length of this side, which would be Q, or this side, which would be P, I would be able to use that information possibly to find the height, because I know that the height of something is going to be perpendicular to the ground. So this would be a 90-degree angle, and if I knew a length of one of these sides, I could find the height using a trig ratio with the Pythagorean identities. So I have sine 105 over 1,000. Let's do sine 35 over, that's angle Q, so that would be the length of side Q. So to solve for Q, I'm going to move Q over to this side, multiply both sides by Q, and multiply this side by 1,000. And then this would be Q times sine 105, and I need to divide by sine 105. All right, so on the calculator, I have 1,000 sine 35 divided by sine, whoops, I'm going to close parentheses, and then I'm going to divide that by sine 105. And I get 593.81. So Q is 593.81, and that would be measured in feet. So that's this side over here, 593.81. Excuse me. So now if I just look at this triangle, so I'm going to just draw this right triangle here. That's 90 degrees. I know this is 40. I know this is 593. And I'm looking to find the height. So if I use a trig ratio with the angle of 40 degrees, opposite and hypotenuse, that would be sine. So I can do sine 40 equals the side opposite, which is h, times the hypotenuse, which is 593.81. And if I divide by 593.81 on both sides, I'm going to have my height is 381.69 feet. Okay, so that's what they're asking to find this height. Number 42 is very similar. They give us a picture and it's asking us to find the height of a bridge over the Royal Gorge. And it says the highest bridge in the world is the bridge over the Royal Gorge of the Arkansas River in Colorado. Sightings to the same point at the water level directly under the bridge are taken from each side of an 880-foot long bridge. So here's our bridge. The length of that is 880 feet. They're taking measurements to this point on the water level. That's down here. This angle of depression is 69.2 degrees. This angle was 65.5 degrees. Okay, so again, we have angle, side, angle. And we're going to use the law of sines for this as well. All right, so the first thing that I need to do, if I'm going to use the law of sines, this is the only side that I know, so I need to know the angle opposite of that. So this angle right here, if I add these up and subtract from 180, I'm going to have 44.3 degrees. All right, so this is one ratio. So I have sine 44.3 over 880 equals, and now, just like I did in the previous problem, to find this height, I need to know the length of one of these sides. So if I say this is point A and this is point B, let's say I want to find this length of this side right here, which is A. So if I know side A, then I can use a Pythagorean identity to find the length of the height. Okay, because this again is a right angle because it's a height and it's perpendicular to the base. All right, so I'm going to use, to find side A, I'm going to use angle A, which is sine 69.2 over A. So I have A times sine, sine of 44.3, can't write, and I'm going to multiply 880 over here And I'm doing that because this is a proportion and cross products are equal. So A is going to be 880 sine 69.2 divided by sine 44.3. And I did the calculations of this and I get 1177.9, and that would be feet. So 177.9. So that's this side right here. All right, so now I'm going to take just this triangle right here, and this is a right angle. This angle is 65.5. So if I use the side opposite over the hypotenuse, that again is sine. So sine of this angle equals h over 1177. Sine of 65.5 equals h times 1177.9. If I'm going to solve for h, I got to divide by 1177.9, and that calculation would give me 1080.2 feet. And that's the height from the top of the bridge down to the water. All right, number 33 or 43. Now this one did not give us a picture, so this is my picture here, and it's a landscaping question. It says that Pat needs to determine the height of a tree. So I drew a tree here, nice beautiful artwork, and I need to find the height of that tree. And it says that he needs to know that height before cutting it down to make sure it won't fall on a nearby fence. The angle of elevation of the tree from one position on a flat path from the tree is 30 degrees. So here, and I don't know the distance from the base of the tree to this angle, but I do know that this is 30 degrees. And a little bit farther, 40 feet farther, so I know from here to here is 40 feet. That angle to the top of the tree is 20 degrees. All right, so I'm trying to find the height of the tree. Now, again, I know that's a right angle because the height is perpendicular to the base. And here, I don't know anything on this triangle except for I have one angle. But on this triangle, I know that this length is 40 feet. So if I knew an angle up here, I could possibly do law of sines, where I would be able to find part of this small triangle. All right, so one thing I do know here is this angle right here. Okay, because this angle is 30, this is going to be the supplement, so this angle right here is 150. So using this angle, this side, and this angle, I have angle, side, angle again, and I can use the law of sines. And to do that, I would need to know the other parts of the triangle. Maybe. Yep, I need to know this angle right here. So if I look at this triangle that's on the left side cut in half here, I know that, I can do this a couple ways. This big triangle, this is a right angle. This angle over here is 20 degrees. So this big angle, that encompasses both of these has to be 70 degrees because these two angles have to add up to 90. So this is 70 degrees. And I know that just this part of the angle, if I just look at this little triangle, 30 plus 60 is 90. So these two have to add up to 90. So this angle over here, if the sum of these add up to 70, this angle is 10. All right, so I need to know that angle because if I'm going to use the law of sines, I need a ratio with an angle and the side opposite. All right, so that ratio is going to be sine of 10 degrees over 40. And what else do we want to find? Can I find the length of this side? And that would be sine of 20 over this value right here. So let's just say it's p. I don't care what it is. So sine of 20 over p. So this side right here, I can find if I solve this equation. So p is going to be 40 times sine 20 divided by sine 10. And the length of that side is 1/5. Nope. What did I do? Let's figure that out here. 40 sine 20 divided by sine 10. 78.78. So that's the length of this side. All right. So if I just look at this triangle, this might be helpful. I know this side is 78.78, and if I use this right triangle here, this is H, this is a number we don't know, this is 78.78, this is 30, and this is 60. All right, so now I can probably use, if I use the reference angle right here, I have opposite H over hypotenuse. So I have sine of 30 equals H over 78.78. So H has to equal sine 30 close parentheses, times 78.78. And I get 39.39. feet, and that is the height of the tree. All right, number 44. Here's another one, no pictures given, but it describes a loading ramp. So here I am here, it's like this is the ground. There's a ramp that's 10 feet long that has an angle of 18 degrees. And it's going to be replaced with another ramp that has an angle of 12 degrees, and we want to know what is the length of this ramp. Okay, so what is the length of this side in here? All right, so again, I have a right angle here. Let's see. So this is 10, this is 18, so I know this little angle in here has to be 6, okay, and I'm trying to find the length of this side. Well, if in this big triangle, this side is 18, then this side must be 72. And if this is 12, then this side must be, oh, what would that be? 78. Sorry, I was thinking about something else. All right, so again, I'm looking for the length of the side, and I just put in all these other things that I knew. This is 78 because 78 plus 12 has to add up to 90. This is 72 because this is 18, so this is 72 plus 18 adds up to 90. But I'm really looking for the length of the side in the middle. So let's draw a picture of that. Okay, so that's just this piece right in here. So this is 10, this is 6, this angle right here is 72. Now I can find this angle because this angle is 78. So if I find the supplement of that, that would be this angle right here. So inside here, 180 minus 78 is 102. So 6 and 72, that's 78 plus 102 is 180. So all three angles add up to 180. So I can use a law of sine now with my 102 degree angle with the side opposite is 10. So I can do sine 102 over 10 equals, and sine 72 over the length of the new ramp. All right, so L will equal 10 times sine 72 divided by sine 102. And when I solve for that, the length of the ramp is going to be 9.72 feet. All right. I know that 45 was assigned, but that was crazy insane. When I first read the problem, I looked at 3 cities. I thought they gave us the angles between each of the 3 cities in the triangle. But what they actually gave us was the latitude, longitude coordinates, and that was just not what I was anticipating. So I'm sorry if you spent a ton of time trying to do that, but that was much farther beyond what I was looking for. So let's cross off number 45 and not worry about that. All right, so there we have those 4 problems, and I hope that that can help you for your quiz tomorrow.